When you check into a hotel and you present your ID, do you ever think that you're giving away far more personal information than necessary? The hotel only wants to prove your identity, but now they also know your age, weight, home address, driver's license number, and more. As soon as you hand it over, you lose control. We're often asked to give away too much of our private data. Once it's out of your hands, that information can become susceptible to hacking, the sale of your personal data, or a barrage of unwanted ads. But what if there was an option to verify your personal information without giving away unnecessary, critical, private details? Verifiable credentials, a pillar of Web 5, solves this. There are digital certificates of claims that are easily shared in a private and secure way. They can prove your legal name, age, ownership of an asset, or anything really. Verifiable credentials limit the amount of data you share to only what's required, and they can't be tampered with or faked. Let's reimagine how identification could work. With Web 5, the government issues a verifiable credential that proves your identity and lives in what we call an identity wallet. So now when you check into the hotel, you present the front desk with a verifiable credential and share only what the hotel needs. This establishes that you are who you say you are, without giving away more personal information than you'd like. Verifiable credentials make proving claims easier, more private, and more secure.
Hey there, everyone. My name is Daniel Buchner. I work on decentralized identity and app platform related work at TBD, which is a business unit of Block. And I have with me Liren Cohen. You want to go ahead and introduce yourself, Liren?
Yeah, I'm a software engineer. I'm focusing on Web 5 and specifically decentralized web nodes, part of Web 5.
Yeah, so I think what we're going to do for this session, because people always asking like, what are we doing? And we kind of finally got one of the last big pillars of our work out there last week, and we wanted to go over everything sort of from soup to nuts on exactly what we have produced and what you can do with it. So this session, you can expect it to be sort of a 101 that dabbles into a little bit of developer related, a little bit of code level stuff. You should walk away with an understanding of kind of all the components in this platform that we built. It's open source and standards based. And look for other videos coming in the next few weeks that are much lower level that speak to primarily only the developer audience, folks who really want to get coding. But this should boot you up. So I guess we can switch over to the slides. So DWeb Deep Dive. This is kind of everything you need to know about the platform. I'll jump right in. The idea here, that we're really going after TBD, through all of our efforts, the undertone is that we think you should have a more you-centric web. The web of today is really about providers. It's about, you giving your data to services, external to you, and, they'll keep a copy of everything. And really it's your identity, who you are, and everything you do spread out over the entire internet. And it's fine to interact with service providers and websites and apps, but if we could have a different model where those institutions and entities were able to provide you similar or the same value without that, with you keeping your own data and identity under your own control, we think that'd be a better web. And this is a vision that many have had, that many I think have been striving for, especially these last 10 years. we hope that the work we've done sort of brings that one step closer, and you can kind of see it as we go through. So the first thing I think to understand is, you probably heard, almost 2 years ago now, we announced that we were going to be building this Web 5 platform. And, some people thought it was kind of a joke, maybe it was, pulling leg of Web 3 and stuff, which is all true. But it's more than that. Having worked at Mozilla, many, many years ago, I'm sort of dating myself, maybe I look a little bit younger than I am, but like 17 years ago, HTML5, if you remember that effort, was something browser vendors did to sort of uplift the web from the document-based like research tool effectively that it was, bulletin boards, stuff that's pretty static, into being an application platform. So that includes stuff like APIs for geolocation and audio tags and local storage and video and all these things that made the web much more vibrant, right? The web that we kind of all know of today and probably take for granted. But those don't exist, right? We needed this initiative called HTML5, which is funny because it wasn't all just augmenting HTML. It was actually augmenting, the entirety of the browser to deliver that. And it took a huge concerted effort, of which I was happy to be a small part of at Mozilla. And it was great, right? It made the web more vibrant, but it didn't really do anything, to fix some critical issues that were sort of with the web from birth. And those issues sort of manifest over the 17 years into greater and greater centralization, which we see all around us today, right? From censorship to silos to honeypots to breaches, like everything is really a result of our choices in the topology of the internet and the World Wide Web. And so our assertion is really that we need an initiative that's of the magnitude and scale of HTML5 to add the missing pieces to make it more decentralized, personal, and under your control. And we would argue that it's really three things. These three pillars will help us do that. Number one is DIDs. You can just think about IDs you own, identifiers you own. Two is verifiable credentials. This is just ways you can form trust and reputation on the internet through standards-based format. And personal data stores. We call our rendition of this DWeb nodes, but effectively data stores that live on your devices and other places that help you store your data. So I'm going to go through each of these three as we go. Liren, I don't know if you wanted to say anything more about sort of the background or setup of the environment, the web, and where we think it should transition to really computational stuff.
Yeah, I mean, you mentioned all of the things that kind of matter. Me as a software engineer, I've always wanted to build experiences that allow users to own their data, but with the way the web is today, that's, as we know, it's quite difficult. So, these standards are going to help hopefully reshape the way that people build software.
Yeah, so kind of taking the first deeper view at that first one that I mentioned, decentralized identifiers, right? IDs, identifiers are different than identity. Identity is kind of the whole of you, but we represent ourselves with identifiers on the internet, which shouldn't be confused with identification. Identification is like when someone demands that you personally reveal who you are, right? Identifiers are just kind of what you see on the left here in common today that we use all over the web. It's like email addresses. That's an identifier. At handles on Twitter, an identifier. Reddit username identifier, right? Even your phone number is an identifier. Anything that you use that can be tied to activities, right? And so today, those are all owned by centralized companies, and entities that, are really in control of them. What we want to transition to is something called decentralized identifiers, which is a standard that was codified by the W3C, the same body that codifies all the web standards for browsers, a couple years ago. And they're really interesting in the sense that you own them. It's sort of like you own your own Bitcoin address. There's people out there, or in the Nostr community, they use their Bitcoin address key npubs as that identifier. You can kind of think of a DID as an identifier you own, just like you own Bitcoin, kind of like a supercharged npub. DIDs are cool because you can actually look up and discover a couple really key things about the identifier. I don't know if you want to go into that a little bit, Liren, talk a little about what it is.
Yeah, so I mean, in the traditional sense, like you mentioned, we have email addresses, we have these handles, and they're just all tied to very specific platform and service providers. To me, when I discovered, the DID standard and how they work, it really reshaped how I thought about all of this. It was kind of the aha light bulb moment for me because, we've all experienced having to, change your email address and how annoying that is. And really, all you wanted to do was change where those emails were stored. You'd have loved to keep just the same email address or identifier. So with DIDs, you're able to publish to your DID your public keys, which allow you to sign things and identify yourself cryptographically on the internet, as well as endpoints of where data could be found. So even the simplest term of this would be you could send emails via DIDs and have a service endpoint for your email address, right? So I think yeah, that power of being able to own and control your internet identifier across services, across different things, is just really, really fundamental and changes the way that I look at developing apps on the internet now.
Yeah, and so sort of contrasting it with other systems, specifically like npubs, for instance, or other systems that use singular keys. There's other ones other than Mustard. Instead of just having one key, you'd have a DID that could have multiple different keys under it. Could be like your npub, right? It could be other keys as well. There's lots of other cryptographic, public key systems that are used for other things like pairing friendly curves for certain kinds of zero knowledge proofs that are much more efficient. So there's reasons why you might have multiple different types of keys. DIDs let you do that, right? They let you associate a group of keys, public keys, with your ID, so anyone can look them up. The endpoints that Liren kind of gave an example to could point to your blog, your web server, could point to really anywhere you want. We think those endpoints really are sort of a replacer for what DNS does, right? You look up a domain name in your browser. What's really happening is it's going to the DNS system and pulling these records down that tell your browser where to go get content from to display the web page. And so DIDs do this in a decentralized way. They have a set of routing endpoints that you, as the owner, can associate with them to direct people to your content. Now, we think that the endpoints should include this thing called a personal data store that we'll get into a little bit later, that allow people to interface with you for app data and personal data. But let's jump into the next pillar. Verifiable credentials, right? I'm not going to spend too much time on this because not a lot of our content has to do with it. But verifiable credentials are pretty much a proving format for assertions. So when I say that, I mean, in this case, we have an issuer, which is it's an educational institution, university, and they might want to make a statement about someone, in this case, Alice, who you can kind of see in the example, that Alice has, graduated with some degree, right? So what they would do is they would take their DID and a key associated with it, and they would sign this verifiable credential that makes the statement that Alice, according to her DID, has this, possesses this knowledge or this fact it's asserting about Alice. Alice can take that credential and then go and prove that, wherever she wants. So if she's applying for a job, for instance, they might say, hey, provide your work history or something of that nature. And she can, in a privacy preserving way, prove that to whoever's asking. And so that's really verifiable credentials in a nutshell. They can stand for anything. They can stand for event tickets. They can stand for, diplomas or, prescription for the doctor, whatever you really want. Just depends on, what the user is doing. The third one, which Liren actually works quite a lot on this particular pillar, is the personal data store aspect. And that's really where the meat of a lot of the Web5 work happens, because that's where all your data, your personal data, your app data is stored. We believe it's a different sort of web. Right now, like we highlighted in the preamble, all your data goes out to these companies and their databases. In the future, imagine if your personal and app data was stored with you, right, through effectively a decentralized database that lives only on your devices and maybe select outbound locations, just enough to have some failover, some replicas that supported any app type. Data can be encrypted. It's not just structured data like JSON or some text, large binary files, movies, pictures of your kids, stuff like that. And when you updated any one of your DWeb nodes, your personal data store on one device, it was synchronized to your other devices and locations of these nodes. It allows for a platform where you can build apps that are local to your device, where they're actually, introspecting your data, where they're presenting, their UI based on the data they get from your DWeb node. I don't know if Liren, you want to add to, some of this, maybe some highlights, features, that sort of thing.
Yeah, I think the replication piece is really, really important. If I'm using some service provider to be highly available, so that when I'm offline, users can access whatever data permission for them. If that service provider no longer is of my liking, I can simply just go into my DID document and replace that service provider's endpoint within the service endpoints, and my data replicates. Again, next time one of my clients comes online, it'll replicate data onto that new service endpoint, and end users really don't see any kind of glitch in the system as far as trying to retrieve data from me, even though I've switched effectively service providers.
Yeah, so we'll touch on a little bit of the topology. This is kind of putting it all together. Like, what does it really look like, when you put these components together? Well, in this case, we have, Alice and Bob, and they each have DWeb nodes, full instances that live on their devices, but they also have these remote instances. And I want to kind of highlight why we would have a remote instance, because people say, oh man, what if you host that on the cloud provider? Now it's centralized. Not so, and for this reason. The only reason you really have remote instances is because you might be offline, right? You get on a plane with your laptop and phone. I just recently flew to Europe, and like miraculously, they're still doing transatlantic flights apparently, where there's like no Wi-Fi, which I thought, I was like, I felt like I was the Wright brothers or something. So there's no Wi-Fi, and I'm like, oh gosh, both my devices. If my DWeb nodes had only been on those two devices, I'd be offline, right? I'd be offline at the time. And if I permissioned someone to get data and it was a critical activity that they needed to drop by and pick that data up, I couldn't do it. So obviously, in the world we have today, without breaking quantum physics, I kind of need something online that people can address. So that's really the only reason here. But the guarding factor is that they're both permissioned and encrypted for the data you want to be permissioned and encrypted. So if you have something sensitive, even if you're hosting this node, this replica at like, a traditional large cloud host, it's not like they can see the encrypted data and the permissions are still enforced. No one's going to be able to actually get a hold of it and read any information that you don't want people to find. In this particular topology here, if Alice wanted to send Bob a message, she would look his DID up, find out those routing endpoints that we highlighted earlier, route to one of his DWN instances that was available, and then make a request, or drop something off, piece of data off. If Bob came online, he was flying like I was a couple weeks ago, his remote node would sync with his locals, and he would be able to get that data, become aware of it. So this is just giving you, an idea of the topology here. So before I go on, we're going to talk about like the app model for this stuff. It's a radically different app model. I'm going to next just go through a few examples of apps that you can, app concepts that you can build using it. So one, towards that goal of a more personal web is, and I don't know, everyone's probably gone through something like this, but I've actually moved, I think, twice in the last 5 years, significant distances. And, you have like 20 different places that, you want to have your address. Right, Amazon, all these other places, they're going to drop stuff off at your house, mail you, government stuff. And so you need them to have your address. But then when you move, you kind of got to remember all these different places. And, you get these, letters. You get these letters for like a year that say, oh, we're redirecting your mail, but not for long. You're really going to lose this stuff soon. And so you're like playing whack-a-mole, right? With these 20 different places that have your addresses. It kind of sucks. You know what I would rather do? I would rather encrypt my current home address location, put it in my DWeb node personal data store, and then just permission these entities to have that real-time view of what my home is, because I want them to have it. And that way, when I change it, they're all just immediately notified. They can even have a subscription push, so it just comes right to their doorstep. They can reflect it in their systems automatically, never have to do that again. That's the web we want. We want a more personal web that's under your control. I don't know if how much you travel, Aaron, but maybe you could speak to this example, traveling itineraries, that sort of thing.
Yeah, I mean, anytime you travel, you have to put in all of this same information, your passport information, date of birth, just all the various information that you have to do to pretty much travel. It would be nice if you could just have that as a part of like a travel app or travel wallet, and you could share that information permissioned specifically for the reservations that you might have, right? I know I would definitely like that if my personal data, especially that type of data, wasn't replicated across so many different providers, right?
And yeah, so I mean, to highlight that, right? Like, think about everything you do on a trip, from restaurant reservations to car rental, everything. There's two companies that really have kingmaker status in this area, which is like Google and Amadeus. You could argue, maybe Microsoft and Outlook, but it's effectively the email companies, because they can read your emails and they can give you these little itinerary snippets, because they're the only ones who can actually see, these reservations coming through. The idea here would be, if these companies put these things that are critical to a trip that you want to do on your trip in your personal data store, you could, like Liren said, use any sort of travel itinerary app, give it permission, and it would then be able to read and display and provide you this view that is an itinerary. And it isn't locked to any of these silos anymore. It isn't sort of the unfair advantage of a couple companies who happen to have access to a feed of that data. It's free, it's open, it's there for developers to make experiences around. I think that's a better web. Last one I'll note is just music, right? Like you kind of regurgitate your playlist, your preferences, and this doesn't just go for music; it goes for all sites. Anywhere where you have to put in a bunch of stuff over and over again, no one enjoys it. Why not have your sort of musical profile with you that just kind of evolves with you over time, because you're storing your personal data store, and you can permit various apps, and multiple apps would like to know this, right? And you probably like them too, like whether it's YouTube or Spotify or Tidal or whatever, right? Probably want to know this information, and provide you a much more personalized experience, right? It's not this, none of these things I've talked about, notice, are just about decentralization for decentralization's sake. People are going to say, well, why are you going to do this? It's like, well, it actually provides a radically better experience if we do this. A web where there's not 1,000 paper cuts, where you're not repeating yourself constantly over and over again, where you're not taking, 10, 20 man hours of time to go and update all your addresses everywhere. These are incredibly tedious tasks that we're trying to alleviate. So
yeah, I think with music, it talks to me specifically because I know that there's different ways to kind of transfer your playlist between these companies, and that's cool. But these streaming companies have become smart enough, based on your listening history and what you've liked and different actions like that you take on individual apps, to provide you a better experience. And anytime you've ever switched music apps, you really just lose out on that, even if you do bring in your playlist, right? So it's like, if you can have all of that data really controlled by you and available to any application, you can really take the fine-grained experience, from one application to another.
Yeah, so we went through some app scenarios. So enough talk. Like let's go in and look at an actual app, right? So this is an app I'm building based on DIDs and personal data stores, DWeb nodes. And you can kind of see here, it is a social app. I'm not going to show all the screens of it, but you kind of see this profile that I've created. Everything in here, from the background images to the profile photos, all this data here, I've actually replicated LinkedIn, got my entire work history going on, and all of it's there, right? Like all of this data is coming from my personal data store, which is awesome because it's actually local, so you can do offline experiences local to you, or you can fetch it remotely from other people's data stores, other people that you want to interface with. So one thing I'll kind of highlight here is that there's other models, and I'll only speak to one. It may be the same with others, but there's like the Nostr model where, some of this data, like this textual data, might be coming from, that network of federated style sort of siloed servers. But the issue is, anyone who just fixates on structured data, there's the binary data too. Like, and what most of them do is they actually end up putting links to centralized locations where those binaries might live, like CDNs, or maybe it's like the wallet provider they happen to be using at the time, has that cache. And that can be problematic, right? Can lead to broken links in content when that churning ecosystem of apps and services maybe going out of business or changing things, like they change their subdomain it's on, all those links break. So one really cool thing here is these actual binaries are stored in your data store too. So you can keep them alive. They're durable links. And I kind of want to go in and show that a little bit. So here's like a little, this is like a little, blog post. This is kind of what this app is, a little bit like Medium. I can live edit this blog post. I can do it on, all this stuff is synced to my personal data store. You can kind of see that, if I reload it, it'll be right there, all updated. Now, one of the really cool things I'm about to show you, and I'll go back to the slide deck for just a moment, because I think we got to walk through it, is this app model. I was kind of talking about it, right? Like, what is our app model? Well, if you know what PWAs are, this app that I showed you is a PWA in all senses of the word. It's locally installable. It does use the web environment, but it's slightly different. It's actually what we call a DWA, decentralized web app. So it's got all the same functionality that PWA has to be an installable web app, but it substitutes a few things, right? So we add this service worker that enables you to interface with a local DWN, so that you're pulling and committing to cache locally with a local DWeb node that's every bit as robust as the ones you have externally, and uses DIDs for resolution of links. So it gives you the ability to have this offline personal experience that also can reach out to other people's DWeb nodes and interface with what we call the decentralized web. One thing I'm going to show you that I think is really compelling, a lot of people have really enjoyed it, is this thing called a decentralized resource locator, which we've actually created and it works today. One line of code as an app developer. In your app, you can activate DRLs, which we're pretty excited about. So you can kind of see up here, traditional web, right? HTTPS, there's a lot that you can tell from just links, right? There's a whole world of different web in these two links. HTTPS alludes to the CA system, a hierarchy of authorities who are effectively in control of the security of this next portion, which is a centralized identifier that a company is offering a service from. Interestingly, they don't even own their IDs, right? This is just leased to them. No company owns their .com. They have a lease, right? We've seen companies lose control of their domain names and that sort of thing. So this is an ID a company holds. You are a row in their database, right? Alice is not. This is not. Your ID is just some manifestation of their back-end service. And then here's some sort of REST API to like an avatar, right? What you'll see with DRLs is that they come from the DWeb. In this case, a DID that is based in BitTorrent. So we actually reuse BitTorrent for these DIDs. That's where they're going and finding their routing information, those keys and endpoints. So you own your ID. And this path to data is actually pointing at a section of data in your personal data store. And the browser actually understands how to resolve these just like normal links. So let me show you what that actually looks like. So I'm gonna look at this, inspect this link here, right? And you're gonna see it looks kind of funky, right? It's got that whole DWeb did sort of as a segment, and then it's got this path to a record, right? And it works just like you would expect any other link to work. With one line of code activating DRLs, you can actually drop a DRL anywhere a normal URL in the web is used. So you could do one in the image tag. It could be like script tag sources. You can use it in fetch. So you can actually go fetch DID documents and resources from personal data stores that way. And we're really excited about it because think about the developer experience here. Once you call this one line of code, you can do gets and fetches and reads from anyone's data store anywhere in the DWeb. And you don't have to know some funky SDK or some one-off thing people wrote. You use the web the way it was intended. So I think it's very friendly to the usability of the web. Let me go back here to... Okay, so DRLs, super exciting. I think you're going to love using them. The other aspect of them that I'm really interested in is they're kind of unbreakable. I don't know if you want to talk about this aspect, Liren. We've kind of talked about it internally a bit.
Yeah, I mean, I think it's pretty cool that you can, because you can drop these in, like you mentioned, script tags, style tags. You can actually host an entire site on these. So you can have your HTML actually stored in your DWeb node and addressed through a DRL. That can pull JavaScript, scripts that are also stored as a DRL, as well as style sheets that are stored as a DRL. So your whole site effectively becomes tied to your DWeb and DID rather than being tied to any kind of like even GitHub pages or something like that you would normally use. I think that really makes for a powerful, decentralized kind of app store experience, even, right? Like these apps, you're actually going to fetch these apps from their publishers' DWeb nodes.
Yeah, so to put a fine point on that, like they enable two things. One is this is like a CDN of you, right? Like CDN links sometimes break when the CDN goes down. The cool thing about these links, if I pointed at the protocol, and we'll get to this concept a little bit, the protocol installed in your DWeb node for profile, and there's an avatar image, I could switch the endpoints under my DID, like where my stuff is from the DID, and these would still work, right? Like let's say I have an outbound node, I start up as a new user, and I'm using some major cloud service for my addressable remote node. And that's like, one of the big cloud companies. I have that associated with my DID. This avatar image lives in my data store, which is accessible there. Well, I become an advanced user and I'm like, you know what? I want to be even more self-sovereign. So not only am I going to have, my DWeb nodes on my devices sort of locally, I'm going to run, a little NUC or desktop server device, and I'm going to put my DWeb node there and get like an ngrok or like a static IP. I'm going to basically expose it to the internet, right? And then I put that in my DID doc. I replace the large cloud company's endpoint with my own that points to my box now that lives at home. And guess what? Nothing breaks. None of the links break because it's still your DID. So whenever you change that endpoint, the next time someone resolves this DRL, it's going to go to that new location, find your data store there at your house, and display that image. So an unbreakable CDN where you can rotate where your location of your DWeb nodes are, never breaking the link references to them. And to highlight what Liren said about apps, you should think about like an unstoppable app. That's kind of what we try to build here, where you might have an app that is represented by a DID, and it has like versions of the app itself, like the actual data that makes up the app from the, the UX and all the images and stuff. That might live in the DWeb node of the app itself. You can go pull those resources, put them in your DWeb node, and then render the app locally from your actual DWeb node, because all the references themselves are DRLs. So that means that like the entire app doesn't even need a DNS domain. And like, how crazy would that be, right? You're viewing a social networking app and there's no domain in the URL bar. It's actually coming from your personal data store. And I think that's pretty exciting. That's the web we need, right? So one announcement we'd like to make, it actually happened last week, but to help this ecosystem out, we worked with Google Cloud and Decentralized Identity Foundation in a joint effort to launch a community-free version of DWeb nodes on Google Cloud. Google's helping to provide this for free. So anyone who wants, without even having a Google account, you can go in and have your DID have about a gig of storage space, virtually unlimited transfer, but a gig of storage space that you can start out with, right? So as a user, you could use a DWeb app, and that might be your default for the time being. It's storing the data locally. It has this remote, and you can get a lot of utilization out of that completely for free. I believe, not aware of any others, but I think this is the first time any decentralized app infrastructure has ever been run, let alone for free, by a major vendor. And I think it's a huge milestone. I hope devs jump in. It lowers the barrier to entry to basically zero. Yeah, I know, Liren, you worked a lot on the DWeb node stuff, so I know this was a big deal. I don't know if you have anything you wanted to add to that.
Yeah, I mean, I think it's great to see large cloud providers get involved and allow us to host it there. I think that one of the coolest things about this is, like you mentioned, I don't think people realize, like, you're not signing up for an account with like your email address. Like, we got rid of all of that. It's just a DID, and you are signing up with your DID to become a tenant in this node. So I think that's pretty remarkable.
Yeah, and let's, again, I'm going to reiterate, right? If you don't want to use this remote node, you always have your data locally on your devices. But if you wanted one that was addressable, and you didn't want to use any provider, you can run this at home rather easily. The entire DWeb node is effectively a TypeScript implementation that runs both in a web page and as a server, and it's really easy to spin one up on your own. So feel free to to do that if you don't want your data anywhere on anyone's server, regardless of being encrypted. So, the last call to action is, hey, let's build, right? Magic Internet apps. I feel like we need this again. Like we need real actual apps. What isn't going to solve the decentralized web is throwing up little portions of our data into feeds that are sort of like run by other companies, right? That's not going to solve it. We actually do need personal data stores. We need a web that wraps around us. We need it to cover all different types of apps, not just social, not just open feed communication stuff, everything. And that's the web we believe in. That's the web we want to see. And we invite you to come do this with us. So, I'll kind of leave it open to be more free form. I don't know if through any of the streaming channels we have any questions that have rolled in. Okay. Yeah. Oh, can I use DWK, which is a form of DID? I'll go back to that screen because, just what is a DID? Like, make sure people understand. Not all DIDs have the full functionality that the DID specification allows for. DWKs are effectively like npubs. JWK stands for JSON Web Key, which is a long-standing standard in the web. It just describes a public key straight up. And it doesn't have one critical thing, which is endpoints, right? So you can't resolve a DWK like SecP DWK to a set of endpoints because there's no network that backs it. And that's a key differentiator with one of the DID methods that we've sort of brought to the fore here, which is DID-DHT, which enables you to store your public keys and endpoint references in BitTorrent tracker entries. So BitTorrent has this thing called Bet44, which allows you to store about 1K with these entries that are basically signed with a ED25519 key. So that's what forms the basis of the network of DID-DHT. It means that you can look up a DID-DHT on BitTorrent and get the payload that you're expecting. So that's the differentiator, and you can't unfortunately use DWK for DRLs. It has to be something that has resolution. I don't know if you want to add to that at all, Aaron.
No, I think you covered that pretty well.
Cool. Any other questions? Okay. How does Google protect from spam if they only require a DID? Well, that's a really good question. There's actually a proof of work module that we built into DWeb nodes that will get excessively more difficult. It's like the first version of proof of work. Hopefully Adam Back's proud if he ever listens to this. I've talked to Adam in person before, but as the creator of Hashcash and the proof of work algorithm that's behind that, it's using proof of work for what it was originally designed for. And actually, they tried it with email first, where you couldn't send an email unless you did a certain amount of proof of work. That's actually what we set up in the DWeb nodes so that you can have this proof of work where if you start getting spam, the work gets harder, the clients have to do more, and that's to limit the number of accounts. So hopefully that, and that's not just a Google thing, but that's it's just built into the open source version. So even if you have one at home, obviously you're not going to let people have a DID space on your home thing, or maybe you might. So you totally block it, but if you run the open thing, it's very easy to configure. How do nodes sync? Liren works the most on sync, so I'm just going to let him talk about that.
Yeah, so basically, the way it works today is your one of your local nodes, the nodes that has signing ability, comes online, and it does a query to see where the remote node's kind of latest watermark is, and it gets a bunch of messages from that point, and it does the same thing in the reverse. It'll push up a bunch of messages from a latest watermark to the remote node. So right now it works on an interval, approximately every 2 minutes. It'll do this kind of back and forth to get them synced. Also, we have something called selective sync, and that will allow you to sync only specific what we call protocols between nodes. So if you want one of your local nodes, you don't want to have all of your data that you've ever had on it. You will permission it to only have access to a specific protocol, and then it will only sync that protocol's data effectively.
So at the risk of going into the code a little bit, because we keep talking about this protocols thing and I want people to understand it, I showed you this app before, okay? I showed you this app, and it looks like it's all just one app with just data. But really under the covers, this is separate protocols that are composable, where this app has asked for permission, in this case, for 2 different protocols. And we put quotes around it because there's the DWeb node protocol, and then there's these data-centric, like, subset protocols that you can install in your DWeb node so it understands certain things. So in our case, there's 2 protocols that work to make up this follow app. There's the profile protocol, which has your avatar, this little background hero. It contains this profile information that you see here. And then there's the social protocol, which does the blog posts and the media for posts. And I'm going to actually show you what that looks like. So here I have, in my code, I've got this little definition, the definition of the social protocol you see here. It's published, so you can have protocols that are installed in your DWeb nodes where no one gets to know that you have them there. And in this case, the protocol has a URI. So this is what distinguishes it. There we go. I messed that up. So this is what distinguishes it, identifies the protocol. We have all of our types. So the things that you might think of in social, right? Follow, aggregators, where I aggregate my social stuff, comments, stories, replies, right? And DWeb nodes have a declarative structure so that you can actually describe how a protocol works. So in some ecosystems, there's things like, like improvement proposals, right? In this case, we went one further. We said, what if you could describe your protocol declaratively and it was actually enforced, right? Like here it's saying, right, the only person writing to aggregators because you don't see one of these actions is me, right? Only person writing to stories is me. You don't see one of these actions. In terms of media, the author of the stories can create, update, and delete media that's added to the stories. Here I have comment, right? I have an action that says anyone can create, update, and delete. And these are centric to their own comments, right? And then I might say, as the moderator of comments, who the author of the story can co-delete, meaning I can delete other people's comments, so I can act as a moderator. It has the full ability to articulate your authorization layer here in declarative JSON, which is super powerful. So we don't have to sit there, and haggle in plain text about how these things work and they're enforced robustly. And B, we can actually define entire protocols within the DWeb node, which I think is really compelling. I don't know if you want to add some stuff to this, Larry.
Yeah, I mean, I think it really just simplifies the idea of making these decentralized apps. Like I don't have to go, as someone that wants to create a new front end for Follow, I don't have to go and kind of ask you or dig through your code and figure out what the rules are. Okay, how does this work and how does that work? I implement the protocol definition, and it's very human readable to see how everything works and who has permissions for what. So I think it just makes building cohesive decentralized apps that work with different front ends just much simpler and really sane.
And let's give you an example. I'll edit this protocol, and let's imagine this was like a personal medical data protocol. I probably would have a role for doctor, right? And let's say that this was test, right? So there's these test objects. I'll get rid of this for a second here. I'm going to grab this actions array right here. I'm going to grab this actions right here and throw it in here. I'm going to say, you know what? Let's go role doctor can create, update, delete, right? Let's just also say that they can query and read. Maybe I don't even want them to delete. I could say, I don't want anyone to delete. I'm going to keep it all. Maybe you mess up and I use it in the lawsuit. So no deleting anything. And this allows you to say, oh, you know what? Anyone who I give the role doctor to, and what that means is like I'm sending them a DWeb record where their DID is the recipient field of that DWeb record. record. They put it up and read the test, right? It's going to check to see if there's a role object of doctor that corresponds with them, and before it allows them to do any of these things. Hopefully I wasn't breaking up there. I don't know. The video seems a little slow on my side, so hopefully that came through.
Just a little bit, but I think most of it came through.
Okay. Yeah, so it's pretty powerful. You can kind of architect any protocol you want. And the beautiful thing, this is like the kind of mind trip here that I'll back up. If you check these out, we went to the DRLs earlier. I'll go to that page. If we check these DRL compositions out, you see how this protocols thing is there? That's what I'm talking about. So protocols, in this case, you can kind of see it. Protocols, follow me here, right? This is the social protocol, and there's like story media, right? Now imagine this DRL wanted to address social story media. This protocols, instead of reading profile, it would read social /story /media. So your actual protocol definitions that are in your DWeb node automatically open up where it's allowed, like where you've permitted someone to read a REST route that mirrors the definition that you create. So that means that you don't have to go do anything to add REST routes. They get created simply based on this, like it'd be story, media, if you had a DRL here, protocols, right? Social, story, media, your DIDs over here, right? And so that's super powerful. Effectively, what DWeb nodes become is like a dynamic REST route, offering dynamic REST routes through the HTTP layer. And we think that's awesome because you don't have to go and mess around with, your favorite router or any of that stuff. They're automatically there. And if you expose this, say, to anyone can read, and it was a blog post or something, anyone can query for that simply by using fetch, the standard interface for getting data over the web. So I don't know if we have any other questions at all or anything came up. Can you speak to latency implications around DRLs? Yeah, super good question. So DRLs, I can actually show you, maybe I'll just show them I can show you the actual thing that resolves it, but where is it? WebJS. Okay, so here we are. This is what makes DRLs happen. It's a service worker. It basically sniffs requests. And the first thing it does is it looks in the request and says, is this a DRL? It's like, okay, great. If it's a match, let's handle it. It jumps in here and says, all right, well, let's do some work. Let's see if we've got a cached response here. I'll blow it up a little bit. Let's see if we've got a cached response. If we do, let's return that right away. But it's important to your question of latency. Well, instead of going to DNS, what are we doing? We're actually going to go out and we're going to go get the DWN endpoints from the decentralized substrate, in this case, BitTorrent. So I look up that DID, I get the endpoints. I'm going to attempt to resolve that content over a normal HTTP call. So at best, you're going to have on a cold non-cached lookup of the DID is really where the time would be. It might be like 3 seconds to get that. If it's a cached DID call, then that'll be instantaneous. Like if you've ever really looked this up in the last time, like 1 or 2x of a native DNS URL resolution. So 1 or 2x native, depending on when you last cached, if that makes sense. Did folks get that?
So this one is talking about the Microsoft Copilot AI that takes a snapshot every 10 seconds. Yes, someone could build something like that is built with DWN first. I would love to see Microsoft adopt that instead of dumping it wherever they're dumping it. And yeah, you effectively would be able to query it and have that data stored locally and replicated on your DWNs rather than, that would be the end goal, to get some of these companies to start doing that with your personal data.
And even imagine the one thing that's pertinent to our times, right? AI, right? Like where, now people use multiple AIs. I do as a programmer, I use a variety of these. They are very helpful when doing certain tasks for like looking up information about something you're writing. And I have like 3 of them that I use, and the prompts and the content, the responses from the AI, where are they stored? Well, in the web pages of the servers of all those AIs. And that's okay, but it kind of sucks. It's like, I'd rather have my prompts and all my responses stored with me, right? So I could keep all that stuff together. But one step further, so that's one use for the data store, and maybe we can offer an API that makes it easy for them to get permissions, which we have for apps, to be able to work on the same corpus of data, just like a playlist across multiple streaming sites. But one turn better would be, what if I took all your personal information? What if you could get it from all these sites and applications? You could put it in your local personal data store, and then LLMs could run on it. So that the same questions you ask about the world around you, right, through an LLM to better understand certain things, you could ask about your own data through the data store. You could say, hey, you know what did I get for people last Christmas, right? And it was just get it, because you had your data imported from all the sources where you purchased stuff. What about, you know what, hey, when did I last get a prescription filled? Oh, okay, cool. That's when? Great, right? Queries about products you've done, financial stuff. Like, let's say you put all your bank statements, your credit card statements in here. Hey, last month, what was my total expenditure? Or how many times did I go out to dinner? And like, what was the cost of that? I'm trying to cut back, That's all really hard to do. There's a lot of dashboard apps that exist out there today that are, one-offs. It's like per vertical. You've got one for financial, one for this, one for that. Super huge pain in the ass. You know what I'd rather? Let's put all this in my data store, and I can just have that same experience of drawn charts and everything I want, but I ask it in natural language.
Yeah, and not to mention, you're giving those dashboards all of your data rather than just having them, permission to that data in a local fashion that doesn't necessarily have to store them on their own servers.
Exactly. So, any other questions that we had come up? I'm curious all right. Is there a concept of time restricted or limited time data sharing? So Liren, you can take this one.
Yeah. So as far as right now, there in the protocol definitions, there are not time restrictions specifically within there. It is something that we have a community member that was talking about implementing themselves, like an expiration of sorts. So you could expire even a role. That could be something that you can do. So it is something that's definitely possible to do, just not exposed yet today. There is more fine-grained permissions, like you can grant specific entities permissions to very specific things, fine-grained, that's outside of these protocol definitions, and those do have expiry. So as far as being able to expire permissions that you granted to someone today, that does exist, but we would like to bubble it up into something like Daniel's writing right now on the protocol definition, and it's something that a community member has mentioned that they're looking to contribute.
Yeah. So this is free form, but duration, you might say in milliseconds. Let's just say it's like I'm not going to type out milliseconds, but let's say it's 6 hours or something, whatever you make it up to be, right? Obviously, in programmatic terms, it's some number, but you can set this, right? And this is the sort of extension point that we hope the community jumps in. Instead of having to quibble about all the parts of a protocol, you can do most of it. Where we do think people can file implementation proposals for us is like new extension points beyond actions. And we have one for size, like where you can limit the size of data. So you could say like the invites can be no bigger than, I think it's like maximum, I set a byte limit. So I don't want them any bigger than 1K, right? So we already have a few of these, but expiry is one that we think is cool, because like if you say you created an inbox with invite objects in them, you might say I want those to expire every 6 hours. Another one we've been thinking of is gating, a gate function, which could have multiple types. Like we could say there's a POW gate, right? And the POW gate would be like difficulty, right? Like how many zeros of difficulty do you need to do to submit me an invite, right? And we can actually automate the the proof of work gating. So there's all sorts of cool little things that the DWeb nodes can actually enforce that we want to make declaratively scriptable, if that makes sense, so that we automate the creation of new protocols. And the one thing that this has up, I believe, on other systems that are in proposal based is like, let's give Nostr for an example, right? You write a bunch of NIPs in Nostr, and then you have to go convince people to support them. And a lot of people end up writing their own one-off relays, like their own like private custom relays. Well, the reality is those are just random servers. Like no one, if they aren't something that other people can transact and do things the same way you're doing it, it's like, it's not compatible. Like you're just using your own thing. The cool thing is that these protocol definitions, you don't have to ask a DWeb node that you may be using to install them. You have the ability, because it's your slice of the DWeb node, you can install whatever you want. There's no permissions. So you can craft your own protocols. You could go convince other users to install your protocols, and you never have to create a custom DWN, right? You can operate within the realm of this sort of composable protocol-based, installation-based environment, which we think is super important, because it provides like a real layer of decentralization in the social scheme, where you don't have to convince people that your way is right. You can say, look, if I get enough users, they'll install it on their DWeb nodes. I'm good. Let's build apps.
Yeah, and having the remote node enforce your rules is really, really important. Like you mentioned Nostr. One of the things with Nostr is that the relays kind of accept all the different nodes, and when you're querying them down, you decide, oh, this is not really valid. This is not really valid. But all that data is still being transferred. It's very much a waste, and it's almost a denial of service. It can be. So this allows the remote node to really enforce the rules that you as the user decide.
Mm-hmm. Yeah, super important. I mean, I think that this is the future. I mean, I hope it is. I hope composable, protocol-based things. And the cool part about protocols is you can ask permission for an app to compose them. So like if you're creating DMs, you can create a protocol for DMs, a protocol for healthcare data, a protocol for all these things that have different requirements, like encryption or what have you. And apps can ask for access. Here. Might have lost me. Am I back?
Yeah.
Okay.
You're cutting in and out again.
These things is the point. I don't know if you want to talk over this. Go ahead, Larry. You can say what I'm trying to.
Yeah. So I mean, yeah. Effectively, you're really able to define these rules for access. You're able to define rules. Who can write, who can read, who can query. You can, I think it's just really, really powerful. It allows you to really express this application in a way that, that different developers can utilize and adhere to the same rules. They don't have to kind of think about, oh, well, what happens when so-and-so tries to write? What am I supposed to do? Am I supposed to just kind of delete that? You're really able to let the DWeb node handle a lot of these errors or these edge cases. And as you can see, the count limit, things like that. These are some features that we're looking to include and add so that you can really enforce these things. I know what Daniel's trying to do here is like on Twitter, you're only allowed to add like 4 pictures or whatever it is to your post. So this would effectively do the same thing, would limit that medias under stories can only have 4 media entries. I think that's really, really powerful.
Yeah. Any other questions that, from the community, if there's anything else? If you're using BitTorrent DRLs, I'm assuming you transit the DRL to IP address. That is correct. So effectively what's happening is we're going and fetching the endpoints that related to the DID. We're forming a valid HTTP URL, and then we're doing queries to those endpoints, returning the data to the worker, and then synthesizing a response so that it can be cached. And you have full control of the DRL caching. Like you can say, I want to cache in my app different DRL resources for different lengths of time. We provide options APIs, very, very simple to use to do that. I can even show what that kind of looks like here. If I go into my little app container, let me go into where it is doing the worker instantiation. So I'm in here in my service worker. Mine, I'm caching all my DRLs for 30 seconds effectively. But I could do something where I'm like sitting here and I go like switch and I'm looking at the route, you know, and I want to do like, you know, maybe it's route dot, I forget if it's like URL or whatever, but maybe it's like route.url or event.url. I think it might be. And so I'm checking that out and I might say like, well, if this URL is case, you know, whatever, right? Or if, you know, I can do ifs or whatever I want and just inspect these. And then I return a different TTL, right? If I wanted, you know, that particular route to be something else, right? Like if, oh no, cache these for a long time. Let's do that for days or whatever, right? So full ability in the activate polyfills on cache check to be able to determine, choose your own adventure there in terms of caching, which I think is super powerful, obviously. Yeah. Any other questions? Happy to answer other questions. We got our little app here. By the way, Follow is an app that I'm going to be putting out here, hoping next month in August. So you'll be able to have a DID-based social app that has, you know, near native resolution via DRLs. It's going to feel very snappy, like Web 2 almost, but you know, obviously using a decentralized substrate. So look out for that. I think that's going to be pretty fun. It's just a personal project I've been working on, but I want people to be able to see the power of this. So there's another question here. DWNs and DWNs can pretty much replace CDNs. If you got multiple DWNs synced, does the DRL handle the load balancing if your personal node is not available offline? Yeah, so they will select between the endpoints of the different instances that you have in your DID doc. It will attempt to resolve across them. It prefs for the zeroth index endpoint. So the one that you put in the zeroth index, it's going to treat as like the primary. It's going to attempt that first, but it will serially attempt others until it gets a positive response. Or if it can't, it'll return a 500 series error to the actual client through fetch, where you as the end developer will either get that success response or something that looks like a HTTP-like error code or other code that tells you what's going on. Yes. Final question, Discord. Besides using tags and a side indexer, is there any plans to improve indexing encrypted data? Yeah, so we do hope. So tags, we did add tags. That's actually another one you can specify in here. I can kind of show you, like you can add tags to your protocol. So you can say, you know what, my story has some tags on it, and those can be whatever you want. So you can set forth, like there's going to be a tag called color, and it's going to have const, like these three. If I'm not doing this right, Larry, just let me know. But
no, that's correct. Yeah.
Blue, right? Like here's a set of choices that you can have for these tags. It'll actually enforce this too. So you can say there's these tags. It has to be one of these, and it's full JSON. It's JSON schema in here. So that's really what the tags actually is. Let you have a JSON schema say like these are the tags, these are the possible values, and you can search over these. These are automatically indexed by the DWeb node, so you can search to see is there a tag? Does it have red? Right? And you could do a few other types of queries. Now, in terms of indexing data, very good question. Beyond like tag search and search on the types of objects and the pathing, we don't offer like rich search over the data because it could be encrypted, right? So if you're going to hit a node and you're going to do this search, let's say you hit the outbound Google node that you're using as a end consumer because you're not running a Freedom box at home, and if you want to search the data, it's going to be encrypted while it's out there, right? So it wasn't profitable in our profitable, not in actual money sense, but profitable dev hours to spend time doing encrypted data search. It's very difficult. It's very performance intensive. It has tons of drawbacks. So what we're hoping is that we can make client side indexing with like fuzzy search, engines really, really easy to do. So that if you're an app and you're given permission to see social, for instance, you can plug in like Fuse or another good local indexer and have fuzzy search over that data because you're pulling it down. It's decrypted locally in your app, and now you're able to do like the full, thing you would want. But that's the reason is encrypted data search very, very difficult, cumbersome. I hope it makes its way in the future, but right, like homomorphic encryption, like Apple just announced, could be the future potentially of search like that. But again, it is very, very slow and performance intensive. So it would really spike the operational cost of remote DWeb nodes quite a bit. Yeah, if there's no other, I don't know if there's any other questions that have accrued through any of the streaming things, but that's pretty much it. I think we've gone for a long time. I'll leave it with the last slide, which I'm hopeful for, which is, hey, come help us build magic internet apps, and not just feeds, not just social. I mean, I know I made a social app, but build anything. Go build private data apps. Like this is not just about public feeds. This is about you, and let's replicate the internet of apps on a more decentralized substrate. Thanks for coming. I appreciate. We're going to do another even more developer focused talk, like much lower level, in the coming weeks. Please join us for that. Until then, hit me up on Twitter at CSU Wildcat. Liren is at It's Liren, and we can answer any other questions, especially for developer. Jump on our Discord. We'll answer questions. We deep dive with people on their ideas and stuff, and we want to make stuff happen for you. So hit us up. Thank you so much. Really appreciate it.
Thanks, everyone.